Okay, so surds. So surds are root numbers. So for example, if we have root 25, now we know the root of 25 is 5, because 5 times 5 gives us 25. So whatever number squared is inside the root. Now, strictly speaking, the root of any number is always plus or minus, but generally when we're dealing with surds we only deal with the plus side of the number. So if we had the root of 16, the root of 16 we know is 4. So this is fairly simple, but you need to know these are root numbers. 5 and 4 are root numbers, and 25 and 16 are square numbers. So you need to know your square numbers. Now if we have for example, if we have root 3 multiplied by root 2. Now I don't know, well I do know that the root of 3 is 1.732, but that's only because I'm sad. But root 3 times root 2 is exactly the same as root 3 multiplied by 2. So this would give us root 6. Okay, this is one of the surd laws. So this helps us, for example, if we have root 2 multiplied by root 18, then that's the same as root 2 times 18. Now 2 times 18 is 36, so this gives me root 36, and the root of 36 you should know is 6. So root 2 multiplied by root 18 gives us a rational number of 6, because root 2 multiplied by root 18 gives us root 2 times 18, which is root 36, which gives us 6. So this is quite simple. Now another rule that we have is that we can have a root, for example, as a fraction. So we can have root 4 over root 9. Now this is the same as the root of 4 over 9. Now we know the root of 4 is 2, and we know the root of 9 is 3. So root 4 over root 3 is the same as the root of 4 over 9, which is 2/3. Now these are basic rules. They're useful if you can remember them, but generally for exam purposes we need to remember this as much as possible. This particularly we need to know. The fractions not so much, but this we do need to know. Now in an exam question, quite often they'll say, let's say root, let's say root 50, and they'll say put root 50 in the form of a root 2. So they know that we can rewrite root 50. Excuse me while I have a fag. So we don't know the root of 50. I know it's 7 and a bit, but I don't know exactly what it is. What I do know is that this is going to help me find this, because when I convert this to this form, I'm going to be left with root 2. So root 2 multiplied by something will give me 50, because I'm going to be left with root 2. Now I know that 2 times 25 is 50. So this is root 2 times 25, and this will always be a square number in the exam. Now I don't know the root of 2. I do know the root of 25 is 5, so that can come outside the bracket. So I'm left with 5 root 2, and this is a surd. Okay, so let's say for example we have root 48, and they say put this in the form of a root 3. Now this 3 is the clue, so root 3 multiplied by something will give me 48. So all I do is I divide 48 by 3, which gives me 16. Again, a square number. I know the square root of 16 is 4, so this comes outside of the root sign, leaving the root 3 inside, which is what they want. So here we can say a is 4. Okay, so let's give you another one. So let's say that they want root 27 in the form a root 3. So again, this is quite simple. I now know that it's 3 times something will give me 27. And 3 nines will give me 27. 9 is a square number. I know that the square root of 9 is 3. So I'm left with 3 outside and the root 3 inside. So a will be 3. Okay, this is a very, very common question, and they'll use this usually as step 1 of the question and then move on to the next question. Okay, so I'll just clear the board, so I pause it, clears the board, and then we'll move on. Okay, so we're back again. So another typical GCSE question. They'll just say to you, what is root 72 plus root 50? Give your answer in surd form. Now they've not given us a clue. They've not said it will be in the form of a root something. Now, just as a tip, whenever I'm looking at these, I always start low. I always pitch low. So are both numbers divisible by 2? So let's try 50 because it's the easiest number. Now 50 divided by 2 gives me 25. Now I know that 25 is a square number, so I think I'm on the right road. So I would divide 72 by 2. Now 72 divided by 2 would be 36. Okay, so root 2 times 36 will give me 72 plus, as I said earlier, 2 times 25 will give me 50. Now my root number is 36, so the root of 36 is 6, leaving me the root 2, plus, now the root of 25 is 5, so this comes out of the bracket, leaving me root 2. So now this is easy. If I've got 6 root 2's and I add another 5 root 2's, then I have 11 root 2. And that will be my answer. So for example, if we had root 48 plus root 27, now again, pitch low. Now I know 2 will go into 48, but 2 won't go into 27, and we very rarely get root numbers that are fractional or decimal. So 2 is no good to me, so 3. Now I know 3 goes into 27. I also know that 3 goes into 48. 4 plus 8 is 12. I know that 3 goes into 12, so 3 will go into 48. So I use 3. So root 3 multiplied by, now 48 divided by 3 is 16, plus, now 3's into 27 goes 9, so I have 3 multiplied by 9. So again I have these square numbers. Square root of 16 is 4, so I'm left with 4 and the root 3 inside, plus square root of 9 is 3, leaving me the root 3 inside. Now if I've got 4 root 3's and 3 root 3's, then I have 7 root 3. Okay, so this is not difficult at all. So if we're adding them, we need to convert them to the same root. Okay, now if we multiply, so if I just explain to you the premise of this, if I have let's say I have 6 multiplied by 6. I know 6 times 6 is 36. Now 6 can be written as the root of 36, because the root of 36 is 6 multiplied by, now this again would be root 36, because the root of 36 is 6. So if the root of 36 multiplied by the root of 36 is exactly the same as 6 multiplied by 6, then our answer will be the same. Root of 36 is 6, multiplied by the root of 36 is 6. 6 times 6 is 36. Now you can see here that this question and this question are identical. So I can see that root 36 multiplied by root 36 gives me whatever is the root. So knowing this, root 7 multiplied by root 7 is 7, by virtue of this same mathematical proof. So the root of 123 multiplied by the root of 123 is 123. And this is very, very useful to us. So if we have, for example, 2 brackets, so we have a bracket, a bracket, a bracket and a bracket. So if I have root 2 plus root 3 multiplied by root 2 plus root 3. Okay, so you can see these brackets are identical. Now they could write this as root 2 plus root 3 all squared. Okay, examiners like to put it like this. It's neater and tidier, I grant them that, but it's just trying to add a little bit of confusion. If anything, squared is itself times itself. So root 2 plus root 3 all squared is just root 2 plus root 3 times root 2 plus root 3. So we expand these brackets exactly the same as we would quadratics. So I urge you to write the lines here. So we have root 2 times root 2. Now remember, this rule applies. So root 2 times root 2 is 2. Now we have root 2 multiplied by root 3. Now remember, root 2 times root 3 is exactly the same as root 2 times 3, which gives us root 6. So I can say that this is plus root 6. Now we have root 3 multiplied by root 2. So root 3 times root 2, 2 times 3 is 6, so we have plus root 6. And then we have root 3 multiplied by root 3, which gives us 3. Now this can be tidied up, so 2 plus 3 is 5, plus root 6 plus root 6, so we have 2 root 6's. Okay, so root 2 plus root 3 squared gives us 5 plus 2 root 6. So let's give you another one. So let's say we've got root 5 plus root 3 and it's all squared. So I rewrite this as root 5 plus root 3 multiplied by root 5 plus root 3, and then I expand. So root 5 times root 5 is just 5. Root 5 times root 3, 5 3s are 15, so we would have plus root 15. Now root 3 times root 5, 3 5s are 15, so this would be plus root 15. And then root 3 multiplied by root 3 would be plus 3. So we can tidy this up, so 5 and 3 is 8, and root 15 plus root 15, that's 2 lots of root 15. Okay, and that will be your answer. So when you're expanding these brackets, use these lines to make sure that you know you've multiplied everything by everything. Then all you need to do is multiply out. Okay, the phone's going, so I'll just pause. Okay, sorry about that. I'm just immensely popular. So, rationalising the denominator. Okay, first off, the denominator is the bottom half of the fraction. Okay, the top is the numerator, bottom, you should know, is the denominator. Rationalising means that they want a rational number. This is a whole number. They don't want to see a root on the bottom. So we've got to convert this somehow so that this now becomes a whole number or disappears altogether. Now if I have 6, for example, and I multiply this by 1, it still equals 6. So any number multiplied by 1 doesn't alter the number. Now 1 comes in many forms. For example, 1 over 1 is 1. 3/3 equals 1. 4/4 equals 1. So we can see that anything over itself is 1. So what we do is we get a little bit tricksy and we say, okay, well, we're going to multiply this by 1. But if I just multiply by 1, the fraction will stay the same. What I do know is that if I multiply root 5 by root 5, I get 5. So instead of having a root on the bottom, I would have a whole number. So knowing this, I multiply by root 5 over root 5, because this is root 5. If this had been root 7, I would have multiplied by root 7 over root 7. Now I know this, root 5 over root 5 is 1, it doesn't alter the value of this. So 3 times root 5 is 3 root 5 over, now root 5 times root 5 we do know is 5, and there we've rationalised the denominator. So this will always work. So if I've got 4 over root 13 and they say rationalise the denominator, I just multiply it by this over itself. So root 13 over root 13. So this will give me 4 times root 13 is 4 root 13, and root 13 multiplied by root 13 is 13. So I've rationalised the denominator. Sometimes they might give you one that will cancel down. So let's say, for example, we've got 3 over root 6. They say rationalise the denominator. Well, we've got root 6 here, so we have root 6 over root 6. So this will give us 3 times root 6 is 3 root 6. Root 6 multiplied by root 6 is 6. Now the root 6 and 6 can't cancel, but these two whole numbers can. So 3 will go into 3 once and 3 will go into 6 twice. So once times root 6 is just root 6, and this will be over 2. So we've rationalised the denominator and we've also taken it to its simplest form. Okay? So if we have, for example, 7 over root 14, they say rationalise the denominator, then obviously I use this, so root 14 over root 14. So 7 times root 14 is 7 root 14, and root 14 multiplied by root 14 is 14. Now the 7 and 14 have a connection, so 7's into 7 goes once, 7's into 14 goes twice. So we're left with 1 times root 14, which is root 14, and that's over 2. Okay, so it's very, very simple. It's a neat little trick which helps us get rid of this root on the bottom. Okay, so that's really as far as I think I need to go on Surds. It can get slightly more complicated, but if you know these basics, then I think you'll be fine for the exam. Okay, so just keep revising and good luck.